Okay, so linear relationships between two quantitative variables are pretty common. Correlation R measures direction and strength of these relationships. When a scatter plot shows a linear relationship, we like to summarize this relationship by drawing a line. A line of regression summarizes the relationship between the two variables, but only when one of the variables explains or predicts the other. Regression, unlike correlation, requires that we have an explanatory variable and a response variable. A regression line is a line that describes how the response variable y changes as an explanatory variable x changes. What is a regression line? A line that describes how a response variable y changes as an explanatory variable x changes. So what is regression to the mean? Well, basically, it's a technical term for things evening out. Specifically, it refers to the tendency of a random variable that is highly distinct from the norm to return to the norm. An example of this would be if a researcher gave a large group of people a test of some sort and selected the top performing 5%, these people would likely score worse on an average if retested. Similarly, if the bottom 5% would likely score better on a retest. In either case, the extremes of the distribution are likely to regress to the mean due to simple luck or natural random variation in the results. One way of thinking about regression to the mean is in terms of sports performance. In order to win a football championship, it is not enough only to be a good team. One needs to be both good and lucky. The team at the top of the standings in mid-season is likely to have been both good and lucky at that point, but cannot count on being lucky for the rest of the season. For this reason, the team that is at the top of the standings at mid-season is more likely to drop in standings than to remain at the top, and more likely to remain at the top than to improve. How does one improve from the top anyway? So, it's a technical term for things evening out. The tendency of a random variable that is highly distinct from the norm to return to norm. Those of you who are in tune with Sports Illustrated, I'm sure you've heard of the Sports Illustrated jinx. The jinx states that a player or team featured on the cover of Sports Illustrated or on a sports magazine such as Sports Illustrated is likely to have a disappointing year the following season. If you think about it, a player is only likely to make the cover once, and for some surprisingly good performance, something truly spectacular that requires not only their superlative skill, but also lots of luck to beat the superlative skills of their competitors. Athletes on the cover of Sports Illustrated are likely to be at the top of their game, and at the top, the most likely direction to move next is down. The next year, although the player may still be skilled, just as skilled, he or she may not be as lucky and post scores closer to the typical. Okay, so what is the general form of a regression line? Regression equation. It is y hat equals a plus bx. In this equation, y hat, and it's read y hat, it's like a little hat over top of them, is the predicted value of the response variable y for a given value of an explanatory x. B is the slope, and A is the y-intercept. Remember that the slope is the amount by which y is predicted to change when x increases by 1 unit. And, of course, A is the y-intercept, the predicted value of y when x is 0. The difference between y and y hat is y hat is the predicted value. Y is the actual value. Y hat is the predicted value. Okay, so what's the difference between y and y hat? Y is the actual value, and x is the predicted value. Okay, AP exam common error. When writing the equation of the regression line, students often forget to include the hat on the y. Make sure that you know the difference between the actual value of y and the predicted value of y hat. This also applies to defining the variables used in a regression equation. So how do we interpret the slope and y-intercept of a regression line? Remember that the slope is the amount by which y is predicted to change when x increases by 1 unit. The y-intercept is the predicted value when of y when x equals 0. Okay, so how do we interpret the slope and y-intercept of a regression line? The slope is the amount by which y is predicted to change when x increases by 1 unit. And the y-intercept is the predicted value of y when x equals 0. Remember, the actual comes from our data. The predicted comes from our regression line. So, what do I always need to say when interpreting the slope to ensure I get full credit? Well, in order to get full credit, you need to state that it is the predicted change in the y variable for each increase in in 1 unit in the x variable. Make sure you use the word predicted. You have to understand the difference between the actual data and the equation we are using to model the data. Remember, the model is a predicted line. Okay, so let's look at this example. The following scatter plot shows the number of miles driven in thousands and advertised price in thousands for 11 used Honda CR-Vs from the 2002 to 2006 model years. The regression line shown on the scatter plot is y hat equals 18,773 minus 86.18x. Interpret the slope and y-intercept in this context. The slope of a negative 86.18 tells us that the predicted price of a used 2002 to 2006 Honda CR-V goes down by $86.18 for each additional 1,000 miles driven. The y-intercept, A, of 18,773 is the predicted price of a used 2002-2006 Honda CR-V with 0 miles. Good luck finding one of these. What is extrapolation? And why is it dangerous? Extrapolation is the use of a regression line to predict far outside the interval of values of our explanatory variable x. used to obtain the line. Such predictions are often not accurate. If we were to predict the price of a car with 50,000 miles on it, this is within our interval of variables, so it's not going to be so difficult to find. 50,000 miles would be 50. If we go up here to our line, if we put that into our calculators, we're going to get that our price is, and that's going to be about $14,464. Reasonable. But should we predict the asking price for a used car using this formula for $250,000? Now that's going to be way outside our realm. If we put that in and predict it, our price is going to be $18,000. Now would be a good time to stop and check your understanding on page 167. Okay, so what is the slope of the regression line, and explain what it means? In context, the slope is 40. We predict that a rat will gain 40 pounds or 40 grams of weight per week. What's the y-intercept, and explain what it means in context? The y-intercept is 100. This suggests that we expect a rat at birth to weigh approximately 100 grams. Predict the rat's weight after 16 weeks. Well, the rat's weight, if we predict it and put it into the formula, into the equation, we predict the rat's weight to be 740 grams. Should you use this line to predict the rat's weight at the age of 2 years? Use the equation to make the prediction and then think about the reasonableness of the result. The time is measured in weeks for this equation, so 2 years becomes 104 weeks. We then predict the rat's weight to be 4,260 grams, which is equivalent to 9.4 pounds. That's a mighty big rat. And it's about the weight of a large newborn human. This is totally unreasonable, and thank God it is, and it's a result of extrapolation. Remember, we can't always extrapolate.